Okay, today is our discussion session about our project in fluid mechanics course. This project is talk about the experiment that we should do to determine the Reynolds number for a pipe flow in different flow regimes like laminar and turbulent flows. So before we start this project, we divide our roles first, like the planner, experimenter, analysis, and report writer, as shown in the slide. So my name is Lin Chung King, metric ID TH19020. I will be the planner in this project, which will plan the experiment and also lead the discussion session. And other member, you can choose the task which you want to do.
Okay, I'm TH19025, Alif Daniel Kobin Afandiko. I'm going to choose the analyst, which will be explaining about the introduction and the conclusion of the experiment.
Okay, the introduction and conclusion is all about Reynolds numbers.
Yeah.
For example, in introduction, you can discuss about what is Reynolds number and the characteristic of laminar, turbulent, and transitional flows.
Yeah, sure.
Okay, other which roles you are to choose?
Okay, I am Muhammad Saiful bin Omar Ali with metric ID TH19023. So the role I choose is experimenter, which is explain the objective of the experiment and do the lab experiment. So the objective of our experiment is we already know, which is Reynolds number, and then the experiment I will do at home with my own material and equipment, and then the data I will provide in the WhatsApp group later.
Okay. So the last role is report writer.
Okay.
I am Devanraj Sidaraman, matrix number TH19015. My role is the report writer for this experiment. So I will discuss about the discussion part for the experiment carried out. So basically, I will explain about the Reynolds number. How does the flow rate affect the Reynolds number? That's all for now.
Okay. Remember, our due date of submission of report is on 8 January 2021. And the experiment that I plan is, I talk about the procedure, the summary procedure of this experiment. Okay, we use the sim pipe and control the flow rate at 5 different flow rate, which is to fill the volume of 1 liter bottles. And the time taken for the water reach 1 liter is recorded in the data. This experiment was taken by Muhammad Saiful and also recorded it in the videos. So the data we recorded and we can use it to calculate the Reynolds number and to define which flow is the laminar or turbulent or transitional flow. So any suggestion for the experiment?
I think no, because the material of the experiment I already have, and then the experiment will be done by today.
Okay, and make sure the internal diameter of the sim pipe is measured initially, because the diameter is also the important parameter for calculating the Reynolds numbers.
Okay.
And in our report, we'll explain how Reynolds number were affected by those parameters like viscosity, density, diameter, and velocity. In our experiment, the velocity and the viscosity is constant for the water at 25 degrees Celsius at room temperatures. So we just use the different flow rate to determine how it affects the Reynolds numbers. Okay, any other question?
Lin, can I ask one question?
Yes.
Like, Saiful, tolong scroll ke atas jap. Okay, stop sini. So, Lin, you look at the instruction part, number 3. For video, it should be within 10 to 15 minutes only. The video must consist of 2 main parts, which are the arrangement of the project and the experimental session. So, experimental session is included introduction, the objective, experimental procedure, and conclusion, right? So, I as the analyst, which will be doing the introduction and the conclusion part, do I need to record the video? Like I'm explaining the introduction and the
You
conclusion.
can explain the introduction and conclusion to Muhammad Saiful, because this experimental session is taken by Muhammad Saiful. It's taken by experimenter. So it will record the video about the four tasks, like intro, objective, experiment, procedure, and also the conclusion.
So Saiful will just, we're going to explain the introduction part lah, like that.
Yes.
In the video.
But you must
okay.
you can brief some introduction and conclusion to Saiful before he do the experiment.
Yeah, sure, we'll do that.
Okay. I think that is all. Steven?
Yeah, what is my role then? I am the report writer, right?
Yes.
So what should I explain about?
Report writer, like you complete the report for
Okay.
submit in Kalam. So you make sure all the report follow the rubric step given by the lecturer.
Okay.
For discussion part, you also can relate the Reynolds number and the flow rate by showing a graph, which Reynolds number against flow rate.
Okay, yeah.
Okay.
Ling, I want to ask you about the conclusion part. What content should I put inside the conclusion part?
You can refer the rubrics in Kalam. Like example, the conclusion about the Reynolds number and some recommendation in the experiment. Okay, I think that is all.
Okay.
I think that's all. Okay.
Yeah, sure.
Okay. Thanks for cooperation.
Okay, thank you.
Assalamualaikum and hi everyone. My name is Muhammad Saiful bin Omar Ali with metric ID TH19023 from University Malaysia Pahang, and I am an experimenter for Group 2 Section 2 BTK1243 Fluid Mechanics subject. So today I will conduct one experiment for our group, which is called Reynolds number.
Okay. Now, let's proceed to the introduction of Reynolds number. So, Reynolds number. Reynolds 1883 was the first to propose a criterion for differentiation between laminar and turbulent flows with the equation NRE equal to density times velocity times diameter over viscosity, or equal to velocity times diameter over velocity. So, fluid flow can be classified to three regimens, which is laminar, transitional, and turbulent. The laminar flow is characterized by fluid particles moving in the form of lamina, sliding over each other. The turbulent flow is characterized by constant agitation and intermixing of fluid particles, such that their velocity changes from point to point and even at the same point from time to time. Lastly, the transitional flow is the flow fluctuates between laminar and turbulent, where before it becomes fully turbulent. So, the objective of this experiment is to be able to determine the Reynolds number as a function of flow rate and to characterize the type of flow of liquid in a circular pipe. In fluid mechanics, a number that indicates whether the flow of fluid in laminar or turbulent flow is by referring the Reynolds number. In case of flow through pipe for value of Reynolds number less than 2000, the flow is laminar, while when Reynolds number is more than 2000, it is turbulent, and for whether Reynolds number more than 2000 and then less than 4000, it is a transition flow. So, the critical velocity average over the cross-section at which laminar pipe flow changes to transitional flow or transitional to turbulent flow. It is believed to be a function primarily of the pipe diameter, the fluid density, and then the fluid dynamic viscosity.
The objective of this experiment is to determine the Reynolds number for a pipe flow in different flow regime, which is laminar and turbulent flow.
So, this is equipment for this experiment. The first is we must have ruler. It is used to measure the diameter of the pipe. Second is the jug with 1 liter indicator. It is used to fill up the water. Third is the sink pipe. It is act as a water supply. Fourth, step. It is used to mark the 1 liter indicator into the jug. 5 is stopwatch. It is used to record the time taken in this experiment. This is the procedure of experiment. Firstly, turn on the sink pipe and set the water in the sink pipe in very slower rate. Second, place the 1 liter water jug in the middle of sink pipe. Third, rotate the sink pipe into the water jug. Fourth, at the same time, start the stopwatch when water fills into the water jug. 5. Stop the stopwatch immediately if the water reach 1 liter line. 6. Record the data. 7. Turn off the sink pipe. And then lastly, repeat step 1 to step 7 with different phase water. First, water slower, weather slower and faster, faster, and lastly, very faster phase. Next, we move to the conclusion of this experiment. So, by the end of this experiment, the Reynolds number as a function of flow rate was determined. It was found out that when the water flow rate is increases, indicate velocity increases, and then the calculated Reynolds number also increases. It can be shown that Reynolds number causes by the velocity of water flow. The laminar flow rate can be determined when the calculated Reynolds number is less than 2000. The turbulent flow rate can be determined when the calculated Reynolds number is more than 2000. So that's all from our group. I hope you enjoyed this video and see you again. Thank you.